For this section, I'm going to go over some of the properties of logarithms, and we're going to focus on three main ones for this section. And the first one is known as the product rule. And so what it looks like is when you have two logarithms that have the same base, and they have different quantities, m and n, if they're being added together, we can actually simplify that so that it's one logarithm, and we multiply the two quantities that are inside of there. Kind of the reasoning behind this is anytime that you have two bases that are the same, you're able to kind of condense the arguments of each logarithm so that you just have one. So for example, if I have log 3, 5 and log 3, 8, I can go ahead and rewrite this so that it says log 3, and then I'm going to take 5 times the 8. Since there's a plus sign, that tells me that I multiply. And so this is going to simplify to log 3, 40. Okay, so if you want to try this next one, go ahead and give it a shot. So for this one, you would rewrite it so it says log base 5, and your quantities are just x and z. So you're just going to kind of write those next to each other like we would with multiplication. And there's nothing that you can do to simplify that further. The next rule is called the quotient rule. And so it's similar to the product rule in that you have to have the same bases, but this time instead of having a plus sign, we have a subtraction sign. And that tells us that we're going to actually divide our arguments instead of multiply them. For example, if we have log 2, 12 and log 2, 4, and we're subtracting, we can rewrite this so it says log 2 and then put 12 over the 4 like that, so it's a division problem. And we can simplify this one step further because 12 divided by 4 would be 3. Okay, go ahead and give number 2 a try. So this is similar to that one that we had earlier with the x and the z. You can write log 6, and then it would be c divided by d. And there's nothing that you can do more with that because they're just letters. The last property I want to talk about is the power rule. So for this one, if you have the logarithm of something, of a quantity that's raised to a power, what we can actually do is take this exponent, in this case p, and move it to the front. So move it back before that logarithm. So we're going to work on just rewriting these. And in the future, when you use the power rule to actually simplify things, if you have numbers that you can actually evaluate with, then we would expect you to do that. For right now, though, we're just going to kind of practice writing them back and forth. So for this first one, we have log 5, 26 to the third power. I could rewrite that so I'm bringing this 3 back to the front of that logarithm. So it says 3 log base 5 of 26. Okay, you guys try number 2. Okay, so we're just going to bring that 4 to the front. So it says 4 log x. Now let's practice going the other way. So this time they have the number sitting in front of the logarithm, so I'm going to take this number 3 and bring it up so that it's now a power for that y. So it's going to say log y and then change that 3 to an exponent. You guys do number 4. So this one, bring that 7, so it's going to say log x to the 7th power. For these last couple of problems, there are times that we maybe need to use more than one rule to simplify something. So I'm going to work through a couple of examples. If you see one and you want to try to do it yourself, I will pause just for a minute and go ahead and let you just kind of pause the video and try them out on your own. And then when you come back, I'll just continue to keep going and work through the problem. All right, so for this first one, what I'm going to do first is bring my numbers in front of the logarithms to my letters as exponents. So it's going to say log 7x to the 3rd plus log 7y to the 8th power. Now, since there is a plus sign in the middle, that means that I can actually multiply my quantities. So my final answer is going to say log 7x to the 3rd y to the 8th. So this next one is very similar to that first one. I'm going to rewrite it using those exponents first. So it says log base 6, and then I'm going to write it as a to the 5th power minus log base 6b to the 3rd power. Now this one has a subtraction sign, so just make sure that you're really careful and you watch for those kind of things, because subtraction means that you're going to actually end up dividing those quantities. So you're going to have log 6, and it's going to be a to the 5th over b to the 3rd. For this next one, you can start to see that we're no longer having letters. We have a 4 and we have a 3, so we're actually probably going to be able to evaluate this down all the way and solve for this logarithm. So what I'm going to do first is rewrite the second half of the logarithm problem so that that 2 becomes an exponent. So it says log base 6 4 plus log base 6 3 squared. So now 3 squared is 9. So I can write this as log 6 4 plus log 6 9. Now since there's a plus sign, that means that I'm multiplying the quantity. So I'm going to be multiplying 4 and 9. So that's going to be log 6 of 36. Now if you remember back in section 3, we were actually solving logarithms, and what we did here is we set this equal to x. And so if we think about what this looked like as an exponential equation, it was that 6, that log base, raised to the x power equals 36. And so I'm trying to figure out 6 to what power is 36. And so if you square 6, if you do 6 squared, you're going to get 2. And so that would be the actual value of this logarithm problem. Okay, these last two are similar to that in that we're actually going to end up evaluating and solving for that x. So starting with number 4 here, I've got log 7, now 7 squared, minus log 7, 7. So log of the 7, that's like that common base. Now 7 squared is going to be 49. The minus sign means that we're going to divide. And we're going to divide by that other 7. So I'm kind of simplifying. I'm not writing everything out step by step. Now you could keep writing it out step by step if you wanted to, but I'm just going to kind of shortcut this a little bit. And so the last thing I'm going to do is have log 7, 7, because 49 divided by 7 is 7. Now I'm going to set this equal to x. Now again, if you think about how would I write this as an exponential equation, it would be 7 to the x power equals 7. Well, anything raised to a power and you end up getting the same quantity means that that exponent had to be a 1. So x is going to equal 1 for number 4. Last one here for number 5. You can go ahead and evaluate this right away if you want to. So it says log 8, And then I would just take 64 and square it. You're going to get a pretty big number. You're going to get 4,096. Then if we set that equal to x, we would have 8 to the x power equals 4,096. And you might have to do a little bit of guessing and checking here. But when you go to do this, x should come out to be 4, because 8 raised to the 4th power is going to be 4,096. Now you could have also taken this problem and moved the exponent to the front. So it looks like this, 2 log 864. So then if we just focus on this portion and we set it equal to x, you would have 8 to the x power equals 64, and you would get x equals 2. Now since you still have this 2 sitting in the front, you'll have to take it times the 2 that we just found for our x. And so you're still going to end up getting x equals 4. So either way would work for you to solve that problem. There are a couple options for that. The one on the right side is just kind of moving things around so you're dealing with smaller numbers. The one that I did originally, you're going to have a big number, but if that doesn't, make you nervous or scared or you don't mind working with big numbers, you can go ahead and just do that method right away.